Okay, hi fourth grade. If you weren't able to come to the meeting where we went through this lesson, this video will help. So what we're doing is we are comparing fractions. Let's see if it says up there. We're comparing fractions, and the skill here is in order to compare which one's greater or less or smaller, you need to have something that's in common. And so two ways to do it. One way is to find a common numerator. You can also find a common denominator. So we're going to talk about how to do that. And it's really pretty easy. I'll show you a couple good tricks. So here you have a length of ribbon is 3/4 of a foot. Another length is 5/6 of a foot. So you're like 3/4 and 5/6. How do I compare these two things? So I want to show you a couple of easy ways to do that. Now, which is greater? Holy cow. One thing you might look at is say, well, this is a piece of pizza. This is 4 slices to make a whole, and I have 3. I have one more slice, and I can have a whole pizza. That's in the 3/4, right? In the 3/4 pizza right here. In my other pizza, I have 6 parts to make a whole, and I have 5. Again, one more slice, and I could have a whole pizza. So let's look at these two pizzas. And you might already be thinking about the size of the slices. That's the key here. That's the key. So let's take a look. If I were to do a pizza here, and I'll do a pizza for 5/6 over here. So 4 slices to make a whole, okay? All right. And this one is 6 slices to make a whole. So then I would do okay. In my first pizza, I have 3 of those. So I've got 3. I'll just kind of lightly color that in with this yellow. And over here I have 6, so I've got 5 pieces, 5 slices, 3, 4, 5. So you might have been able to look ahead and say, oh, 4 slices, only 4 to make a whole versus 6 to make a whole. And if you were thinking ahead and said, oh, if it's 6 of those to make a whole, they're going to be smaller. And that's exactly what the case is here. They're smaller slices. So in both cases, I've got 1 slice left to make a whole, but this one is a lot bigger than this one. So one way to compare is just to draw. You can always just draw them, for the most part. Another way is to let's have them have a common, in this case, denominator. So I'll show you the easiest way to do that. They've got a bunch of stuff over here, but I'm just going to show you. Here's the easiest way to do that, is just to go back to with your multiplication and do some skip counting. You're going to skip count. You're going to skip count by 4, skip count by 6, okay? And then you're going to make an equivalent fraction. In other words, you're just going to rename each of these fractions. And it's really that easy. Don't let it intimidate you. So if we skip count by 4 and 6, so skip count by 4, I have 4, 8, 12, 16, okay? And what's going on here is I'm saying if I have 4 slices to make a whole, if I cut everything into 2 parts, I'll just do that right across here like this, then I would have 8 to make a whole. I'd have 8. If I cut everything into instead of into 2 parts, if I cut it into 3 parts, I would draw 2 lines. Now everything's been cut into 3 parts, and if you add up all those pieces, you find it is 12. There's where the 12 comes from down here, the 12. So that's what we're doing when we're skip count. We're kind of like using a pizza cutter. Let's see if I can get those off. We're actually just cutting pizza without a pizza cutter. We're just down here, we're just listing what would happen if we were to cut the pizza. So let's talk about what would happen if we cut this pizza here. 6, the one with 6. If I cut it into 2 parts, I'd have 12. If I cut it into 3 parts, 18. But already I'm seeing a common, that's this word up here, a common. That means something that's the same with both of them. There it is, that 12 denominator. That's the same. That's the same. Again, if I cut the first pizza into 3 parts like this, which I could do with my pizza cutter, that would give me 12. If I cut this one in half, that would give me 12. And although the slices look different, although this one, looks different, it's a little bit fatter and this one's taller and skinnier, they are actually naming the same amount. So you'd have to imagine, kind of taking that pizza out. Maybe I'd have to cut a little bit, but if I were to make, I could make this one into kind of like what this piece over here, this perfect square. And what tells us that is that they have the same number to make a whole, okay? So in fact, this one now, my new name for this pizza, this slice, we do a different color here, would be, if I added up all the parts that are shaded in, 3, 6, 9, it'd be 9/12. And over here, if I added these parts that are shaded in over here, these two, that would be 2/12. And that's where they got this from. Oh no, sorry, that's the one that's open. Sorry. If I added up the part that was shaded in, that's all this part back here. This is the part that's actually shaded, okay? It's shaded in yellow. That last piece there, I better take that off. Basically what that's showing you. See if I can get that off of there. Hold on, let me fix it real fast. Okay, what we're talking about over here again is I've got all of these 5 pieces that were shaded, and then remember, I cut this so that there's 12. Sorry, there's 12 to go. So now how many slices? 1, I can shade them in blue. 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10/12. And that's where the 10/12 comes here. And there's the 9/12 we just did. So you could draw that. Or you could just do this part. Look, just skip count. And let's come down here and take a look. Just skip count, like I said. Now we're going to do this part called an equivalent fraction. So let's come down here and we'll say, okay, I'm going to make 3/4. I skip counted and I found it was 12. 12 is the denominator that I am going to use. So I'm just going to skip count and get that. So now all I have to do is say, okay, well, how many slices will be shaded in? Because I know how many slices for the whole pizza. So basically, I'm tripling the number of slices to make a whole pizza. That's 4 times 3 is 12, which means whatever was shaded in, I also tripled. 3 times 3 is 9. And it sounds like you're making more pizza, but you're really not making more pizza. What you're doing is you are making more slices, but they're smaller. So what I've just done is I have, and again, if you look at the picture up there, if you look back at the picture, what I've said is that 3/4, this part here, is equivalent to, I just wrote a new fraction that renames it with smaller pieces. And that's exactly what we did up here. I had 3 big slices, but when I cut the pizza, they became 9 little slices, but it's the same amount. Same amount. Same with this other one. This other one, I had 5 big slices, but then when I cut them in half, they became 10 little slices, but I'm going to naming, or if I ate those 10 little slices, it would be the same amount of pizza. Okay, so let's come back and we'll do the, let's make our other equivalent fraction. We're on this step right here, making an equivalent fraction. So now I have, my fraction was 5/6. I'm going to make it so that it has 12 slices. That means I'm doubling them, right? 6 times 2. And I also cut in half the ones that were shaded, so that means times 2. And that's how you do it. That's how you do it. So now I just rename them up here. Look, it's not 3/4 anymore. It is now 9/12. It's not 5/6 anymore. It's now 10/12, naming the same amount of pizza. And now I can compare these. I can say, oh, well, look, 12ths and 12ths are the same. So 9 slices out of 12 is definitely less than, so I'm pointing to the smaller number. 9 slices out of 12 is less than 10 slices out of 12. And that's how they got this. And I guess I should have left this up because now I know 3/4 is less than 5/6. And that's how they got this part down here. All right, that's basically what this lesson's about. I'm going to do a quick pause because I have to go teach a lesson, then I'll come back. Okay. I am back, so I had to pause that, and then we're going to finish this up. So we're looking at this whole, there's stuff all over the place here, but hopefully you followed that, and we're going to look at a common numerator or denominator in order to compare. Okay, so here we go. All right, let me clean some of this up a little bit. Pause it. Okay, so this first one here, it says we're going to be comparing 3/4 and 5/6, and we're going to use that with drawing some models, some tape diagrams, or pizzas is the easiest way to think of it. And then we're going to do the same thing, but we're going to make the denominators the same down here. So it's going to be the same fractions. So 1 and 2 go together. Up here first, we're just going to shade it, compare the pizzas or the tape diagrams, and then down here in number 2, make the denominators the same. Remember, that was part of our lesson. This lesson is how can we make, part of our lesson is we want to make a common numerator or denominator. Okay, one of those two will help us to compare. Here we go. So we're going to do show 3/4, which is, see if it'll let me do my highlighter. It doesn't do that. Let's try 3/4 and 5/6. So 3/4 means, let's go back to what that means. 3/4 means four parts to make a whole, and we have 3 of those parts. So let's shade that in, take a look at it. So we have 1, 2, 3. That's 3/4 right there. Down below we have 5/6. Remember what that means? That means we have 6 parts to make a whole and 5 shaded in. Okay, and I'll just kind of get this guy out of the way. Okay, let's come down here. 5 shaded. 1, 2, 3, 4, 5. And so it's pretty easy to see now. Well, 3/4 is less than 5/6. This is actually a really interesting problem, though, because this pizza here, you could think of it, this pizza 3/4 has only one more piece to make a whole. Only one more. And this pizza down here, 5/6, has only one more piece to make a whole. So it's interesting because 3 out of 4, if I had one more piece, I would have 4/4. 5/6, if I had one more piece, I'd have 6/6. So they're the same because, in a way, they're the same because each needs one piece. Problem is, these denominators tell something totally different. Look how small the 6 parts are compared to the 4 parts. So 5/6 is really a lot closer. Just one more little piece, you'd have a whole. Okay? This needs, 3/4 needs a much larger piece to have a whole. Okay, so that's another way to think about it. Okay, now, still another way to do this is, what you're going to be doing more and more of, is to just basically cut these pizzas into where they have the same number of parts. So let's start with this one. If I cut each one of these, if I double the number of slices, so in other words, I'm gonna cut each of these slices, including, I'm gonna pretend like in this part, even though there's no pizza there, I have to pretend like I'm cutting everything in half, which basically what I'm doing is I am doubling the number of pizzas. This will now, number of slices. This will now means that I have 12 slices to make a whole, and you can see I have 1, if you count 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I had 5 slices, but I doubled the number to make a whole. Show you what that looks like too. Let's do the whole thing here. Let me get this out of the way real fast, because this is basically the part you wanna catch here. Okay. I started with 5/6. I doubled the number of slices so that I now have 12 parts. That means I also doubled the number of slices that were shaded in. 10/12. 10/12. So that's what this is. Let's look at the first one now. If I'm going to get 12 slices out of this pizza, I have 4 slices, 4 spots where I can put a slice. Gonna have to cut each of those into 3 pieces. That way when I count, it'll be 3, 6, 9. That'll give me 12 total up here. Okay, so now I have 12. Okay. So what did I do? Well, I had 3/4, and I said I know that I can have a common denominator of 12, so I tripled the number of slices to make a whole pizza. And in doing so, I tripled the number. I had just 3 slices that were shaded in, tripled them. That gives me 9. And you can count them. You can count them up there, okay? So now it's really easy for me to compare. The denominators are the same. That means the slices, this size, that slice, that's the same amount as this. So now it's super easy to compare. Okay. Let's take a look at the next one here. Number 3, compare 2/3, okay, and 9/12 by finding a common denominator. Okay. Write a fraction equivalent to 2/3 with a denominator of 12. In other words, here's what they're doing with all these boxes. They're saying, I have 2/3. Let's put it over here so it's a little easier. I want to make a pizza with 12 total slices. I got a pizza with 3 parts to make a whole. I want a pizza with 12 parts. I'm going to have to cut that up. I am going to have to quadruple the number of slices. Again, not making more. They're actually going to be smaller because I'm cutting. I'm making more pieces, but smaller. Then, if I quadruple the total number of that's on my pizza plate, then I'm also quadrupling the number of slices I have. I'm cutting those up, and I'm making those 2 into 8 really small slices. And that's what they're doing over here. You can just fill that in if you want, like this. Okay, 8/12. And then they have 9/12. Well, 9/12, I don't need to do anything to it. So 8/12, go over here. 8/12 is less than 9/12. Now, I want you to watch this because remember, all I did was, let me show you over here. All I did was take, 2/3, and because I multiplied by the same thing, I just renamed that fraction to 8/12. That's all I did. Okay, no big deal there. I just renamed it. So for example, if this was the pizza down here, I had 2/3, watch. Okay, and if I had that pizza there, and I had 2/3 down here like this, all I'm going to do is cut it up so that it has 12 parts. So I'm going to cut each one of these into 4. Well, yeah, that's fine. Now remember, this was shaded in. That was supposed to be shaded in, okay? And then I cut this into 4 parts. Oops, didn't get my new color. And I got to cut this into 4 parts. Whew, it's hard to do. So you can't see those little teeny ones, but remember this was also shaded in, okay? So now look, I have 1, 2, 3, 4, 5, 6, 7, and that one's shaded in too. I have 8. So my new fraction is 8/12. So I'm just renaming. That's all you're doing. It's an equivalent fraction. Renaming it. Same amount of pizza. So in other words, 2/3 then is less than 9/12. Okay? All right. You can stop that and go back and check it out. All right, let's compare. Okay, now we got to read really carefully on this one. So this one says, this time we're going to compare 1/5 and 2/12. But this time, last one we did, we got the denominator to be the same, and that made it easy to compare. This time, we are going to get the numerator the same, and that will make it easier to compare. So let's come over here and let's look over here. 1/5, and we're going to compare that to 2/12. Well, you know what I could do? If I doubled this numerator and doubled the number of slices, I could get a numerator of 2. Okay? In other words, if I had a pizza cut into 5 parts, 1, 2, 3, 4. One of those were shaded. And I wanted to compare it to this pizza with 2 slices shaded in. Okay, so this pizza is 2 out of 12, which means I'm going to have to do it like this. 1, 2, 3, 4, 5, 6, and I'll cut that in half, okay? Because those are really small pieces. So if I want to get 2 slices of pizza, like I did here, I'm going to have to cut this one into 2 smaller slices. So what happens when I do that? Well, watch. If I cut it, I get 2 slices, but I also, whenever you cut that pizza, or whenever I multiply, in this case, you're multiplying it times 2. I also just doubled the whole number of slices, so now I have 10. They're smaller, so I haven't changed anything. So what I did was, I'll show you. I said 1/5. When I cut it with that line, I doubled the number of slices, right? I had 5. I doubled it. Now I have 10. So I also doubled the number of pieces I have. Again, I didn't make more. They're smaller. I have more pieces, but they're smaller. Hey, well, now I can compare this. Look, so instead of 1/5, let's go up and I'll put 2/10 here. So now I have 2, and 2 are the same. So each of these pizzas has 2 slices. Now I got to do some thinking. That's where you got to know what this numerator business means, because denominator. This denominator means 10 slices, 2 out of 10, and this means 12. So this denominator, there's more slices. So that tells you they have to be smaller. Okay. They have to be smaller. Now it's harder to see in this. It's hard to see, like, unless you draw it really well. But you can kind of see in my drawing, this is a little bit bigger than this. You can see it a little bit, okay? Oops. Maybe it's a little fatter on mine. But basically, if you just have to know, you have to know in this case, you have, oh, okay, all right, 12 is more slices. They're going to be smaller. So that's how I know. 2/10 is less than 2/12. So guess what? That means that 1/5, that's my original fraction. Remember that original one? I kind of erased it there, didn't I? Now 2/10 is just right equal to 1/5. So in other words, 1/5 is also greater than, right? 2/12 is less than 2/10. That means it's also less than 1/5. So let's see, what do they do? Here we go. Times 2 times 2. 1 times 2 is 2. And now we have, compare the fractions, 2/10, okay, is greater than 2/12. And so 1/5 is greater, okay? All right, so let's come back. We'll look at the next set. Okay, I just made a mistake. I had worked all this out for number 5, and I did not record it. So we're going to have to do it again. So we're going to compare 2/5 and 8/10. So I'm saying I can see right away, if I double the number of pieces to make a whole, I can get a denominator of 10. So I'll double that, and I have to double the number of slices there. That gives me 10 and 4. So 4/10 is less than 8/10. So 2/5 is also less than. Ta-da! Now this time I'm going to do 5/12. And I'm going to put 1/3 over here. And I'm going to work from 1/3 over to 12, because I'm going to see, look, if I multiply 3 times 4, if I quadruple the number of slices, I can get 12, just like I have over here. And of course I have to quadruple what I have shaded in. That equals 4/12. 5/12 is greater than 4/12, which is also greater than 1/3. So 5/12 greater, just like that. All right, let's take a look at the next one here. This is 3/5, and 60 hundredths. So I'm looking at this and I can see, you know what I might do is if I multiply, what can I multiply? 3 times 2 is 6. So look at this. 3 times 2 will give me 6. Now I want 60. So if I need another shift, so I'll do 3 times 20. That will give me 3 times 2 is 6, and I get to shift over 1 0. All right, so I'm going to try times 20. That will give me 60. Times 20 down here. 5 times 2. So let's look at that. 5 times 20. 5 times 2 is 10, and a 0. That will give me 100. Whoa, how cool is that? They are equal. And in fact, there's some pretty neat things you can do, because later on I can tell you, you can know exactly how many hundredths, 1/5 and 2/5 and all it is. It's just a memorized fact. But for right now, 60 hundredths equals 60 hundredths, and so 3/5 is also equal. Ta-da! Okay, my last one here on this section is 9 hundredths and 9 tenths. So I can compare these. I've got 9. I've got 9 slices. Now imagine a pizza with 100 slices. Okay, it's going to be hard to make here. 1, 2, 3, 4, 5, 6, 7, 2. Then I got to go across this way. Okay, that's got 100, and then I'm going to fill in 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if you got a pizza, if someone offers you 9 hundredths of a pizza, they are small, tiny slices, and it's pretty easy to beat that deal. 9 tenths is going to look way better, right? So let's do 1, 2, 3, 4, 5. That's 5 big slices. Cut it in half. There's 10. Shade in 9. 1, 2. I've already blown it away, right? 3, 4, 5, 6. In fact, you could also look at this and say, oh, wait a minute. 1, 2, 3, 4, 5, 6. I made that too big. I'm sorry. I have to come back and fix that real fast. Hold on. Hold everything. 1, 2, 3. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5. Yeah. 1, 2, 3, 4, 5. There we go. I got to take just this one out right here. Okay. So in fact, another observation you can have, another way to do this, is says this one right here is one more piece, and you will have a whole pizza. Just one more. This one needs 91 more slices. Way smaller. Okay. All right, let's take a look at the next one. Okay, so we're going to look at this next section here. It says tell whether each sentence is true or false. So we're going to look at 2/3, and we're going to compare that to 5, 6. So we want the numerators or the denominators to be the same so we can compare. Well, it looks to me if we double the number of slices to make a whole, we'll get 6 parts. And that means we have to double the number of slices we have. That's 4. Now we can compare. And 4, 6 is less than 5, 6. So 2/3 should be less than. Oh, they got that one wrong. 2/3 is less than. All right, let's look at the next one. 4 tenths and 4/5. Whoops, sorry. Oh, this one's not so bad. We have the same number of slices. So we have 4 slices, but we have, if this is our pizza, 4 slices of pizza, but the pizza's cut into 10 parts. Over here, 4 slices, it's only cut into 5 parts. These are going to be smaller. Those are going to be 4 smaller slices. They got that one right. 4 tenths is less than 4/5. Look at the next one. 70 hundredths and 7/10. I don't have equal numerators or denominators to compare, so let's go with the denominator, because I know 10 times 10, whoops, kind of going backwards, so I wrote it backwards. 10 times 10 is equal to 100, kind of going backwards here. So that means I have to multiply this times 10. I did it again. 10 times 7 is 70. Those are equal. So actually, 7/10 is the same as 70 hundredths. That's true. One third and 3/1. So 1/3 means 1 part out of 3 parts. 3/1 means that I have 1 part to make a whole, just one big part. I didn't actually draw that very well. One big part to make a whole. And I have 3 of those. They pulled a sneaky one on you. They're just saying you have 3 whole pizzas. So obviously 1/3 is less than 3/1. And remember, 3/1 is just the same as 3. 1/3 is, nope, that's false. Clear this out of the way. I'll do my last one here. 3/4 and 2/3. So this is a sneaky one here, because now I have to pick something that I can multiply to get both these denominators or numerators the same. So if I think of it, let me show you. If I think of this though, and I'm going to have to use some space down here that you won't be able to use. So you may want to use just another piece of paper. But if I think about it, 4. Now if I multiply 4 times 2, I get 8. 4 times 3, I get 12. So if I have this pizza and I double the number of slices, I get 12. 8. If I triple them, I get 12. Now I have the pizza with 3 slices. If I double the number of slices in the pizza, 3 times 2, I get 6. If I triple it, I get 9. If I quadruple it, times 4, I get 12. I can get the same denominator here. I have to multiply this one. Got to triple that one. 9/12. And then I'm going to have to quadruple this one. 8/12. Boy, they are really close. Really close. 9/12, however, is greater than 8/12. So 3/4 is greater than 2/3. Did they get it right? They got it wrong. They got it wrong. That one's false. All right, so listen, you learned a really important thing. Finding a common, making those denominators the same is a super, super important skill. Okay, hold on here. Let's look at what this last thing says. Look at our last question. Can two fractions with the same numerator and different denominators be equal? Well, let's test it out. So it's too hard to think about. So we want 2 fractions, same numerator. So let's pick a 2 and a 2 for our numerator. But different denominators. So let's pick a 3 here and a 4 here. Can those be equal? And the answer is, what do you think? This one has 3 slices. The whole is cut into 3. This, it's cut into 4. Those can't be equal. The pieces won't be the same size, will they? Let's try something else. Let's try something else. What if you try, because the numerator has to be the same. What if this is 10, and we'll just say this is 5? 2 slices, but again, if the numerators are different, or if the denominators are different, that means the size of the pizza slice is different. So the answer is no. They can never be equal. you may have the same number of parts, but the parts will not be the same size. That's the problem. Or you could talk about pizza. There's a lot of ways to do it. Okay, that is basically that. I'm going to pause here. Okay, well, we're done with this. This is making sure if we're going to compare, we have a common, something that's the same. We can either have the numerator be the same, or we can have the denominator be the same. And that's the way we compare fractions. We use the denominator a lot. Great job. Remember, on these tapes, on these videos, you can stop and start.